Okay, this is Math Lesson 6.1, Part 1. I hope that you watched the two videos on Schoology that kind of reviewed fractions for you. I think it would be best if you paused the video and did page 325 and 326 and then came back to see if your answers were correct. So pause for a minute and then come back and see me for page 325 and 326. Okay, so what you need to know about fractions is that there are two numbers and it's part of a number. It's not a whole number. So if you look at this shape right here, there are four parts all together, and then one of those parts is shaded in. So we would read that as 1 out of 4 or 1/4. Number 2 shows 1 out of 5 shaded, or 1/5. Make sure you get that TH on the end of it. And number 3 shows you 1/3 or 1 out of 3. This also says 1 divided by 3. I'm going to show you a little trick here. We could have an improper fraction where the top is bigger than the bottom, and we had 24 thirds. This is the same as saying 24, and this line means divided by 3, and that would give us 8 whole. We would have 8 whole pieces. So that's a little preview of where we're going to be going. Part 2, name the shaded part. We have 1 out of 2 parts shaded. On number 5, there are 5 out of 6 parts shaded. Number 6, we see 2 out of 5 parts shaded, or 2/5. Now, if you don't know this already, the top number is called the numerator, and I remember that as numero 1, like if you remember from Spanish, numero 1, it's up on top. The bottom number is called the denominator, and the way I remember that is D is down for down. So the denominator is on the bottom. That's how many parts there are all together. And then the numerator is how many parts shaded in. Okay, on this next section, it says color the fraction strips to show the fractions, then circle the greater fraction. So here we would shade in 1 out of 2 parts. And on this one, we would shade 1 out of 3 parts. Now, if you look at the parts, 1/2 is the bigger fraction, even though it has a smaller denominator. So one thing I want to show you is that the bigger the denominator, the smaller the piece is going to be. I want you to think of this like a sheet cake, and you split it into halves or you split it into thirds. Well, if you split it into thirds, even though that 3 seems like it's a bigger number, it's actually dividing the sheet cake into smaller pieces. So on number 8, they show us 1/5, so we're going to shade that in, and here they show us 1/3. So which part is bigger? 1/3. So even though 5 seems like it's bigger than 3, it's not when it comes to fractions. If the denominator is smaller, it's going to be if the denominator is bigger, that means it's going to be a smaller part. Now, if you did this question here, Earth's surface is covered by more than 57 million square miles of land. The table shows about how much of Earth's land surface each continent covers. Which continent covers the greatest part of Earth's land surface? Okay, so here's for instance, if we would treat these fractions like a cake, 1/8 is going to be the whole earth, and it's going to be just one little part out of 8. Here's 1/6, 7 100ths. Okay, that would mean we divide the whole cake or the whole earth into 100 pieces, and you're only going to get 7 of them. Here you're only going to get 6 out of 100. Here's 9 out of 100. Now this one's interesting. It's 1/5. So if we divided the earth into parts, 1/5 is definitely going to be bigger than 8ths or 100ths. What about this 3/10? Well, here's what I'm going to do. I'm going to change this fifths into tenths. This is something we're going to be learning how to do today to see if which one of these is bigger. So I'm going to say to myself, 5 times what number is 10? The answer is 2. If I multiply the denominator by 2, I have to multiply the numerator by 2. And I get 2 times 1 is 2. So now we have 2/10 is equal to 1/5. So 2/10 and 3/10. So I'm going to think to myself, if I had a cake and it was divided up into 10 pieces and I wanted to eat more, I'm going to want the 3/10 because 3/10 is bigger than 2/10. So our answer to this question is Asia. Okay, now we're going to go to page 326. Okay, and complete the flow map by using the words with a check mark next to them. So let's see here. We've got 6, 1, 2, 3, and 6. I'm thinking if I did a factor rainbow, 1 and 6, and 2 and 3, that means these numbers here are factors, or a factor. Now here we've got 6, and then it's got 6, 12, 18, 24. Seems to me like we are counting by 6s. That means it is showing us multiples of 6. So the word multiple goes there. Okay, we've got 1/6, 2/3, 4/5. Those are all showing us fractions. All right, if we look at this fraction, it's pointing to the number on the bottom that's down. Down is the denominator. All right, and here they are circled the top number, so we want number 1, numero uno, that's the numerator. Now, if you used your vocabulary pages to fill in 1, 2, 3, and 4, we know that a fraction is in simplest form if the numerator and denominator have only 1 as a common factor. And we're going to learn about simplest form a little bit later this week, okay, or maybe next week. Equivalent fractions. They didn't really give us enough room to write here. Name the same amount. Number 3, a common denominator is a common multiple of 2 or more denominators. We're going to learn about common denominators. Remember when we found common factors and common multiples? Now we're going to find common denominators. Number 4, a benchmark is a known size or amount that helps you understand a different size or amount. Okay, now we're going to go to page 327. Now, the book is going to show you with pictures. I'm going to show you the way Mrs. Pruitt was taught when she was in probably 6th or 7th grade, and you're now learning it in 4th grade. So they're going to show you with a picture. and that's going to give us the concept, but then I'm going to teach you a way to find an equivalent fraction that's always going to work for you. Okay, here it says Joe cut a pan of lasagna into third size pieces. Okay, that's what we're seeing here. 1, 2, 3. He kept 1/3, so they've kind of got this shaded in here, and he gave the rest away. Joe will not eat his part all at once. How can he cut his part into smaller, equal pieces? So it says, draw on the model to show how Joe could cut his part of the lasagna into 2 equal pieces. Okay, well, let's see how many pieces or little tiny cubes they have here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we've got 5 by 8, which would 5 times 8 would be 40. So we want to cut this 40 in half. Half of 40 would be 20. So we've got 5, 10, 15, 20. So I'm going to cut it in half like that. Okay, so you can rename, and what we're going to do is kind of extend this line. So I want to show you that originally he had 1/3. So we got 1/3, 2/3, and 3/3. Now I divided that into half, and now instead of having 3 parts, I have 6 parts. So he cut, suppose Joe had cut the original pan of lasagna into pieces of this size. How many pieces would there be? 1, 2, 3, 4, 5, 6. What fraction of the pan is 1 piece? Okay, so now we've got it into 6. So we've got 6 parts altogether, and just 1 piece would be 1/6. What fraction of the pan is 2 pieces? That would be 2 out of 6. So we can rename 1/3 as 2/6. Okay, I'm going to now show you the way I would have done this. If I want to change 1/3 and make an equivalent fraction, I'm going to multiply both the numerator and the denominator by the same number. So let's just pick 2. We're going to multiply the denominator by 2, and we're going to multiply the numerator by 2. 2 times 1 is 2, and 2 times 3 is 6. So I know that 1/3 is equal to 2/6. I'm going to do another one just for fun. Let's say I have 1/3, and I want to make another equivalent fraction besides 2/6. Instead of multiplying by 2, I could multiply both the numerator and the denominator by, let's try 4. So I'm going to multiply by 4 and multiply by 4. 4 times 1 is 4. 4 times 3 is 12. 1/3 is equal to 4/12. So I'm just giving you that little shortcut where you won't have to draw all these pictures out. So now it says, now draw on the model to show how Joe could cut his part of the lasagna into 4 equal pieces. Okay, so remember how there were 80 squares all together, and half of that was 40. So they're wanting to divide this into 4 equal pieces. So if you could do that in your head real quick, it would be like 80 divided by 4. And we know 4 goes into 8 2 times. Or we can think 40 times 20 would equal 80. All right, so if we want 4 equal pieces, we're going to have 20 of these little cubes in each one. So we've got 5, oh, not 20. Yeah. No, we want 10 in each one. How did I do that? Okay, so we're going to divide his part. let's see, 10, 20, 30, 40. Sorry, this should have been by 4, which changes that to 1. Okay. Sorry about that. I didn't count the squares. All right, so now we're dividing the lasagna into 4 equal pieces, his little part. But let's just extend those lines right there. Okay. So now, instead of having 4 pieces, we've got 12 pieces. What fraction of the pan is 1 piece? So we're going to shade in this little part right here. So I've got 12 pieces all together, and I've shaded in this part right here, and that is 1 out of 12. What fraction of the pan is 4 pieces? Well, if we shaded in all 4 pieces, now we have 4 out of 12. So we can rename this 1/3 as 4/12. Now, I'm going to do this another way. You could put 1/3, and we want to, right up here, we did this problem already, we're going to multiply by 4. So 4 times 1 is 4, and 4 times 3 is 12. So here's the fun thing. 1/3, when we divided it, or not divided, when we multiplied the numerator and the denominator by 2, we got an equivalent fraction of 2/6. When we took 1/3 and we multiplied both the denominator and the numerator and the denominator by 4, we got 4/12. I could do another one here. Let's do 1/3 and find an equivalent fraction by multiplying both the numerator and the denominator by 3. 3 times 1 is 3. 3 times 3 is 9. So 1/3 is also equal to 3/9. All right, let's go to page 328. Excuse me. Okay, compare the models for 1/3 and 2/6. How does the number of parts relate to the sizes of the parts? Okay, so 2/6 has twice as many equal parts as 1/3. Okay, and we can do that like a multiplication problem. 1/3 times 2/2, so we're going to do twice as many, is equal to 2/6, because 1 times 2 is 2 and 3 times 2 is 6. So 2/6 is going to have twice as many equal parts. Describe how the numerators are related and how the denominators are related in 1/3 is equal to 2/6. So it's kind of the same explanation. The numerator and the denominator, all right, so I'll write it out here. The numerator and denominator in 2/6 are twice as many, or twice as big, twice as many as 1/3. So we just showed that in a multiplication problem right here. Okay, let's figure out, does 1/3 equal 3/9? Oops, I already showed you this. Let's try it here. 1/3, all right, 3/9. I'm going to show you how you can, there's 2 ways you could figure this out. I'm going to show you the long way, and I'm going to show you a fast way. Okay, think to yourself, 1 time, let's start with the denominator. 3 times what number will equal 9? Well, that answer is 3. 3 times 3 is 9. And then I have to multiply the top by the same number. 3 times 1 is 3. So do they equal each other? Yes. Okay, that's the long way. Here is the fast way to find out if two fractions are equal to each other. You are going to do something called cross multiplying. So I'm going to take this denominator times this numerator. I'm going to go across. 3 times 3 is 9. Okay, then I'm going to take this denominator and multiply by this numerator, and I get 9. If you get the same number up here, they are equal. Okay? All right, down here at the bottom, Savannah has 2/4 yard of ribbon, and Isabel has 3/8 yard of ribbon. How can you determine whether Savannah and Isabel have the same length of ribbon? The equal sign and not equal sign show whether fractions are equivalent. Tell whether 2/4 and 3/8 are equivalent. Okay, I'm going to show you on the picture, but then I'm going to show you this faster way to figure out if they're equivalent. Okay, shade the amount of ribbon that Savannah has. Savannah has 2/4. Okay, so we did that. Shade the amount of ribbon that Isabel has. Isabel has 3/8. So if we made the ribbons the same exact size here, you can see that 2/4 is bigger than 3/8. Well, I'm going to show you the faster way to do this. 2/4 and 3/8. Are they equal? Are they not equal? Let's figure that out. We're going to cross multiply. Okay, we got 4 times 3, we get 12. Here we have 8 times 2 is 16. Are 16 and 12 equal? No, they are not. So we would put not equal. So 2/4 actually is, well, we're not comparing them yet. I was going to say 2/4 is actually bigger than 3/8. But here we're just saying if they're equal or not equal. Okay? And let's go to page 329. Use the model to write an equivalent fraction. Okay, I'm going to show you how to use the model. I'm also going to show you the faster way to make an equivalent fraction. The key here is equivalent fraction, meaning it's got to be equal. So you could take 3, 6, 9, 12, 15, 18 and divide that in half. So 3, 6, 9 and divide that all the way across. Okay, now, I don't know if you can see that on the video. Okay, now you, instead of having 5 equal pieces, you have 10 equal pieces. So if you shade in, I'm going to do 3, 6, 9. Okay, go across like this. Okay, so now instead of having 1 out of 5, you have 2 out of 10. Well, the way they also got that is to multiply the numerator and the denominator by the same number. So if we're doubling it, we're going to multiply by 2 and by 2. 2 times 1 is 2. 2 times 5 is 10. So we know that 1/5 is equal to 2/10. Right here, we've got 2 long bars out of 3 shaded in. And what they want us to do is, well, there are several ways we can do this. We could make this, divide this in 1, 2, 3, 4. So I could make this 1, 2, 3, 4. I could divide it like the picture like that. Or we could use the method I showed you. Let's double it. We could do 2/3 times by 2 times by 2. We could get 2 times 2 is 4 and 3 times 2 is 6. Or if we use this picture, now it's out of ninths. Okay, so I've got 1, 2, 3, 4, 5, 6, 6 ninths. So to get that, I would have taken 2/3 times 3. So 3 times 3 is 9, and 2 times 3 is 6. So both 4/6 is a correct answer, or 6 ninths. The book has 6 ninths because they divided it up into 9 equal parts. Okay, we're going to do the fast method here. Tell whether the fractions are equivalent. Write equal or not equal. All right, remember how I taught you to cross multiply? So 6 times 2 is 12. 12 times 1 is 12, and that means that these are equal. Here's another way you can test this. If you think to yourself, 6 times what number is 12? That answer is 2. And then that if I multiply by 2 on the bottom, I have to multiply by 2 on the top, and 2 times 1 is 2. If you get that number on the other side, then they are equal. I just think it's faster to cross multiply. Okay, 5 times 6 is 30. 10 times 2 is 20. That means these are not equal. Okay, let's not cross multiply. Let's try multiplying. Think 3 times what number is 12? Well, 3 times 4. So because I multiply by 4 here, I also have to multiply by 4 here. 1 times 4 is 4. So 3 times 4 is 12. 4 times 1 is 4. That means these are equal. Now let's go back to cross multiplying because I think that's faster. 8 times 2 is 16. 4 times 5 is 20. We didn't get the same number, so these are not equal. 6 times 10 is 60. 12 times 5 is 60. That means these are equal. You could also think of this one in your head. Is 5 out of 10 half of 10? Yes. So is 1/2 going to be equal to that? Yes. So we could also cross multiply. 2 times 5 is 10, and 10 times 1 is 10. That means these are equal. Okay, Manny used 8 tenth-size parts to model 8 tenths. Anna used fewer parts to model an equivalent fraction. How does the size of a part in Anna's model compare to the size of a 10th size part? What size part did Anna use? Okay, if Manny had 8 tenths and Anna used smaller parts, we could just divide these both by 2. 10 divided by 2 would be 5, and 8 divided by 2 would be 4. So Anna used fifths. Okay, fifths, F-I-F-T-H, fifths. Okay. And how do her parts compare? So actually her fifths are going to be larger than the tenths, because like say you had a candy bar here and we divided it into fifths. Okay, Anna uses 4 fifths, but 8 tenths would mean we would divide this in half here. Now we've got 10 equal parts, and we've got 2, 4, 6, 8. And those parts are smaller. So I hope you can see that. How many 8-size parts do you need to model 3/4? All right, well, let's do 3/4, and we're going to make it equal 8ths. Think to yourself, 4 times what number will equal 8? 2. So if I multiply the denominator by 2, I also have to multiply the numerator by 2. And 2 times 3 is 6. So it says, how many 8th size parts do you need to model 3/4? Well, if we want it to be equal, we need 6 eighth size parts. Okay, this side here, look at the pictures. It says Ben brought 2 pizzas to a party. He says that since 1/4, so if you would like extend the lines there, since 1/4 of each pizza is left, the amount of each pizza, he says that since 1/4 of each pizza is left, the same amount of each pizza is left. What's his error? Well, yes, they both have 1/4, but are the pizzas the same size, the same shape? No. So the error is the pizzas are not the same size. So we can't really compare them. If we did like a circle here and we shaded in 1/4, okay, we could have another one where we did fourths, but instead divide that up again. So instead of into fourths, it's into eighths, and then we could shade this in, and then those two would be equal because 1/4 is equal to 2 eighths. And we know that because 4 times 2 is 8, 8 times 1 is 8, they are equal. Okay, down at the bottom here, for numbers 12a to 12d, tell whether the fractions are equivalent by selecting the correct symbol. Okay, you can use the shortcut. 6 times 3 is 18. 15 times 1 is 15. So these are not equal. This one's, I might actually have to use my calculator here, but I'm just going to work it out. I know that 3 times 20 is 60. And I've got 16 times 4. 4 times 6 is 24. Carry the 2. 1 times 4 is 4. Plus 2 is 60. 64. Oh, 60 and 64 not equal. Okay. Here we got 3 times 8, 24. 12 times 2, 24. That means these are equal. 5 times 8, 40. 10 times 4, 40. That means they are equal. Okay, so now you need to go to Clever, and there is a Part 1, 6.1, Part 1 assignment for you to do. All right, see you tomorrow.